I'm also. Today we are going to discuss another two very important topics regarding alkanes. The one of them is isomerism. Okay. Now, what is the meaning of this isomerism? Actually, that is made up of two words. The one iso means same, right? And merism is the word which comes from mer, means apart or the molecule. So same molecules. Okay, when we say same molecules, what does that mean? The same molecule means there is some similarity between the two molecules. So actually, isomerism is the word which is derived from the word isomer. Okay. So isomers means same molecules. Whenever the word iso, it indicates same. Now let's talk about the similarity. And look at this. These two molecules I am using their one of the molecule made up of four carbon atoms. And you can see it's a straight chain of carbon atoms which have hydrogens bonded with it like this. So if I want to name this compound, I will focus on the longest continuous chain of carbon atoms. For simplicity, I'm not drawing the hydrogen atoms, right? Okay, so if I number them 1 and 2 and 3 and 4, so as we did the naming of these alkanes, why it is alkane? Because you can see there is carbon, carbon, single bond, right? So for 4, we use the word but. And now the ending name should be ANE. Why? Because there is carbon, carbon, single bond. It means this molecule belongs to alkane series, right? So the ending part should be ANE. Okay. So it's a butane. But if I take this example, let's see this one. Again, you can see I have four carbon atoms, but you can see there is a difference in their arrangement. And if I place the hydrogen atoms, so three hydrogens with this carbon, one with this, three with this, and three with this. But you can see in this case, the longest chain is of three carbon atoms. And this carbon, which is not the part of the chain, that is known as a branch. Is it clear? So if we look at their molecular formulas, you can see here how many carbon atoms are there? There are four carbon atoms. And if I count the hydrogen atoms, so 3 and 2, 5 and 2, 7 and 3, 10. So C4H10. But here again, 3 and 3, 6 and 3, 9 and 1, 10. So it's also a butane with the same molecular formula, C4H10. But you can see there is a difference in their structure. Remember one thing, when we write butane like this, C4H10, it is called molecular formula. Is it clear? We call it molecular formula. But when we draw the butane like this, showing all the bonds, so we call it displayed formula, right? The displayed formula of simple straight chain butane and displayed formula of this butane, which has a branch in it. A straight chain having one carbon atom. Remember one thing, hydrogen cannot be considered as a branch. We always consider carbon atom as a branch. So the longest chain is of three carbon atoms here, and one of the carbon that is a branch on it. So They have, you can see, different structure, but they have same molecular formula. So we can say that isomers are those molecules or those compounds having same molecular formula, but what's the difference? Different structure. Is it clear? So those compounds which show this property, they are called isomers of each other. So we can say this simple butane, straight chain butane, and this one is a branched butane, which will definitely have a different name according to the rules. But I am calling it butane. Why? Because I want to differentiate between them, the straight chain and the branched chain. I will say branched chain. Otherwise, if I talk about the name of this compound, it will have a special name, which is methyl propane. The naming is not the main concern right now. But here, what we are basically concerned with, we have to look into the different structures and we have to identify whether they are isomers of each other or not. So these two molecules, they are isomers of each other. For practice, right now, let me take one another example. For example, sometimes if the molecule is drawn like this, I can see it is very easy. How can we simply differentiate whether the molecules they are isomers of each other or not? You just have to focus on the chain of carbon and circle it. So it is very clear. It is a very simple straight chain. Okay. And there are two ends of this simple chain, no branch on it. Because remember, hydrogen will not be considered as a branch. So here we have hydrogens attached with these carbon atoms. Okay. Now, here, if the structure is drawn like this, is it a branch? No, it's again straight chain. Why? How can I know? I will again simply select the chain of the carbon atoms. You can see I have encircled the carbon atoms. So here I can see there are two ends. If I hold this end and the other end and stretch it. So on stretching this molecule, you will get the structure like this. Again, simple straight chain. So no branch on it. So two ends, hold them and stretch them, you will get a simple straight chain. So similarly, it's not an isomer of this molecule. So remember, if you have three carbon atoms or you have two carbon atoms, so no isomer is possible. Simple straight chain is possible. But if you have carbon atoms four or more than four, then you can observe the isomers. Okay, let's see here. I am, for the simplicity, I am drawing only the carbon atoms. I'm not drawing the hydrogen atoms, right? Like this. Okay. So what I will do, I will encircle the carbon atoms, right? So it's a straight chain. If the structure is given like this, is it a straight chain or a branched structure? So, what simple rule I no, it's not a branched. How? Look at this. You just have to encircle the carbon atoms, right? You are going to encircle. So, there are two ends of this molecule. This is A, one end, and the other end is this. If you hold these two ends and stretch them, so on stretching, you will see it will give you this straight chain structure again. So no branch on it. Is it clear? Similarly, if the structure is drawn like this, is it a straight chain or branched? So how can you identify? Just encircle the carbon atoms, right? Like this. Okay. Now you can see there are two ends. Hold these two ends and stretch them. You will get again straight chain structure like this. So all these are same molecules. They are not isomers because they are just a different ways of presentation of their structure. It's a simple straight chain molecule. But if you have a molecule like this, having carbon atoms in it, now if you draw and circle the carbon atoms, so there are two possibilities. Either you can draw the continuous chain of carbon like this, or there is another possibility. You can consider this one as a longest chain, or you can consider this one. So maximum
Can't we?
you, sorry,
Can't we do this?
no, actually, when you insert draw like this, as you said, look at this. Let me draw here the three carbon atoms, sorry, four. You are encircling the carbon atoms like this, right? Now, if you encircle them like this, so how many ends of this molecule you have? You have one end, the another second, and the three ends of this molecule, isn't it? So remember one thing, when you encircle the carbon atom's longest chain, so there should be two ends as I selected in this case, A and B, two ends. Here you can see there are only two ends, one and two. But here,
What if there was another one over here? Could we make it like this?
which one?
Made and drawing. Yeah, like that.
No, here you can see again there are two ends, this one and this one, isn't it? So A
Yes.
and B, two ends. Whether you can practice it, you will see either two ends or more than two ends. So in this case, I can see there are three ends. So it's not a straight chain. So what we will do, we will select this one, which is easier for us. So it's like this. So straight chain of three carbon atoms, and this carbon is out of the chain. So what do we call this carbon, which is not the part of the longest chain? We call it a branch. Is it clear? So sometimes we call it simply branch for our simplicity. Otherwise, we call it substituent. Is it clear? So whenever we want to decide between two structures whether they are isomers of each other or not, the easiest way is to encircle the carbon atoms. That will give you a simple and easy way to find out the isomers. And these isomers, they are called structural isomers. Why? You can see they have same molecular formula but different structure, a straight chain or a branched chain. So now let's try one more example. Okay, I am going to draw this structure. Okay, a five carbon atoms, one, two, three, four, and five. For simplicity, I am not drawing the hydrogen atoms, right? Okay, this one, this one, this one. Now we have to decide among these whether they are isomers of each other or not. So what I will do, I will select the longest chain. First of all, look at this. That is my longest chain here. So how many ends are there? One and two. Because if I hold these two ends and stretch them, I will get a simple straight chain structure. So no branch in this structure. Okay. Now let's try this one. Here, that is my longest chain. And again, I am observing two ends, A and B. If I hold these two ends and stretch them, I will get the same long chain structure, no branch in it. So these two molecules, they are same, just a different way of presentation. Otherwise, they are not isomers of each other. Okay. Now let's try this one. Here, again, I have these carbon atoms. Okay. So how many ends? I can see there is this one end, this one end. So if I hold these two ends and stretch them, I will get a simple straight chain structures like these two. So all these three, they are same molecules. But now let's try this one. Here I have this structure. So the longest one, two, three, and four carbon atoms. So this carbon is out of that longest chain. So that is our branch, or you can say this carbon is acting as a substituent. So here we can see this end and this end. If we hold them and stretch them, so which type of structure I will actually get? So I will get this type of structure, four carbon atoms of the longest chain, and there is one substituent on this carbon here, like this. So these four carbon atoms of the longest chain, one, two, three, and four, and there is one carbon as a substituent. So you can draw this molecule like straight chain and one carbon as a branch. The rest are hydrogens like this. Or the another way of presentation is this one. So we can see in all these five structures, let me label one and two and three. So one, two, and three, they are same molecule, but different ways of presentation. But this one, fourth, so you can say one, two, and three, same molecule, but one and four, or two or four, or three or four, they are isomers of each other. So you can say this one, two, and three, they are straight chain structures, no branch in it. They are straight chain structures, right? No branches in it. While this one is a branched structure, right? So total five carbon atoms, either straight chain or branched structure. Okay, now let's try another example. With the structures like this, three, four, five, and six. It's a simple six carbon atoms molecule. So it's formula. Okay, according to the general formula of the alkanes, what should be the formula? C6, how many hydrogen atoms do I need? If I use
Well,
the, no, for alkanes. CnH2 and plus 2. 6 2s are 12 plus 2, 14 hydrogen atoms will be there. So I want to draw its possible structures which are isomers of it. So what I will do, I will take simple these straight chain 6 carbon atoms. Now I will take 5 out of these carbon atoms as a straight chain, and I will draw one of the carbon as a branch, right? Okay, what if I take these 5 carbon atoms like this, 4 and 5, and I take the sixth carbon here? Is it a branch? Can we consider this carbon as a branch? No. Why? Because when you select the longest chain, it will become the part of this longest chain. So remember the first carbon on either side, right or left, that cannot have a branch on it. So branch will always be on the second carbon or third or fourth and whatsoever. But first carbon on either end, right, that cannot have a branch on it. Is it clear? Like this. It's not a branch, it's a simple straight chain, 6 carbon atoms, right? Okay, now let's try another isomer of this molecule. So 6 carbon atoms with simple straight chain. 5 I have drawn as a straight chain and the sixth one as a branch. Okay. 5 carbon atoms as a straight chain. And now I am placing a branch here at the third carbon. So these are isomers of each other because you can see it's a simple straight chain. Here the branch is on which carbon? Second carbon, right? Here I have a branch on third carbon. So these three are isomers of each other because they have same molecular formula, right? C6 and H14, C6 and H14, but they have different structures. So that's why we call them structural isomers, or we call them chain isomers of each other. Is it clear? That is a type of structural isomers. Okay, now let's try this one. If I have 6 carbon atoms like this, okay, now again I have 6 carbon atoms. But here you can see if I select the longest chain, so I will get the maximum 4 carbon atoms. So here we have 2 branches on it. So that means that more than one branches are also possible in the molecules, right? So if we have more carbon atoms, so there are possibilities of more than one branches on it. Got it? So what is now isomers, or what is the phenomena of isomerism? Actually, the existence of molecules having same molecular, or the compounds, you will say, same molecular formula, but different structures. So which type of questions will be asked? So they will ask to identify the molecules, whether they are isomers of each other or not. So now let's see few examples. Okay. What about this A, B, and C? They are isomers of each other. We'll talk later, but right now here. In these two examples, how can I identify they are isomers of each other? I will encircle the carbon atoms, right? And here you can see a chain of 4 carbon atoms. Here, a chain of three carbon atoms, and the fourth one is as a branch, right? So they are isomers of each other, having same molecular formula C4H10 as we discussed earlier. Is it clear? Okay. Here, remember one thing that isomers, as you can see, they have same type of bonding. So they will have same chemical properties and they are members of alkane series. But as you can see, they have different structures. So they will have different physical properties, right? Now look at this. If we have a straight chain molecule like this, I am drawing one straight chain molecule, right? Another straight chain molecule like this. So when these two molecules come closer to each other, so there are strong intermolecular forces. But if we have a branch structure like this, one molecule and another similar branched molecule, like this. I'm drawing straight chain. It's a straight chain, right? And this one is branched. So you can see that straight chain molecules when come closer, so they are parallel to each other and stronger attractive forces between them. But when branched molecules come near to each other, so they cannot come as closer as the straight chain. So there are weak intermolecular forces. So remember one thing that straight chain structures will have higher melting and boiling point. As you can see, the boiling point of straight chain structure that is 0 degrees Celsius. But the branched chain isomer of the same molecule, its boiling point is minus 10 degrees Celsius. What's the reason behind it? The stronger intermolecular forces in straight chain. In branched structures, they will have lower boiling point. So as you can see here, compounds with branched chain has lower boiling points. Molecules cannot get so close together. So it takes less energy to separate them. Is it clear? Okay. Now, on these bases, let's try these molecules, whether they are isomers of each other or not. So the structure A, we have a chain of two carbon atoms. Here we have a chain of two carbon atoms, a chain of two carbon atoms. So all these three have same number of carbon atoms and it's a two carbon atom chain. But what's the difference? Here we have a branch of bromine atom, and here again bromine atom. So you can see that A and B, they are similar structures. But what's the difference in case of C? You have a branch of two bromine atoms. So that means that A and B, they are same molecules, which are not isomers of each other. But what about C? C is a different molecule. Why? Because when I make the molecular formula of this A, it will be C2, 1, 2, 3, and 4, and 5. 5 hydrogens and Br. The molecular formula of this B, that is again C2, H5, and Br. So A and B have same molecular formula and also they have same structure. So they are not isomers of each other, right? But what about C? Is it a same molecule? How many carbon atoms are there? There are two carbon atoms. How many hydrogens are there? One, two, three, and four. And there are bromine atoms too. As you can see, It's a different molecular formula. So C is not an isomer, it is a different molecule. Is it clear? So as they are saying, A and B are not structural isomers, both have the same molecular formula and same structure. But what about B and C? They are not structural isomers. Why? Because they have different molecular formula. So for isomerism, the compounds must have same molecular formula but different structures. Is it clear? So remember one thing, isomers are called structural. There are different types of isomerism. So today we discussed about structural isomerism, right?
Yes.
Isomers in which molecules have same molecular formula but different structures. Even though there are different types of structural isomerisms are also as we discussed, that is chain isomerism. We have done that. There is another type of isomerism which is called functional group. We'll discuss later on. Functional group isomerism. There is another type like position isomerism, right? So, different types of isomerism, but today we discussed about this one, chain isomerism, which is a part of structural isomerism. Is it clear? So, which type of questions will be asked? Different structures will be shown and they will ask to find whether they are isomers of each other. And the easiest way is to encircle the carbon atoms. It will give you a clear display and you can simply identify whether it's a straight chain or it's a branch chain compound. Is it clear?
Yes.
So this is about isomerism.